U.S. forces working to restore freedom of navigation through the Strait of Hormuz while maintaining the naval blockade against Iran. President Trump warning Tehran any interference or attacks will be dealt with forcefully.
At 0340 local time, a rocket booster ignites on the flight deck of a United States Navy warship cutting through the Persian Gulf at 41 knots. A small delta-wing aircraft punches into the night sky, 10 feet tall, 8 foot wingspan. It carries a warhead that costs less than a decent used car. Then a second one launches. Then a third. Within 4 minutes, 23 of them are airborne, climbing northeast toward the Iranian coastline. The ship that launched them cost $600 million. It broke on its maiden voyage. This is the story of why the United States Navy sent its most embarrassing program to do the job that its most expensive platforms could not touch. And why the ship that Congress wanted to cancel just rewrote the doctrine of naval warfare for the next 50 years. The Littoral Combat Ship. The program that produced 2 classes, each broken in a completely different way, and somehow both necessary for what was about to happen in the Strait of Hormuz. The Freedom class variant was built around a propulsion concept that looked elegant on paper. 2 diesel engines and 2 gas turbines feeding power through a single combining gearbox into the drive system. The torque loads that Gearbox experienced exceeded what the gear teeth could physically sustain. They ground themselves into metal dust while the ship was underway. USS Milwaukee, LCS-5, lost propulsion on her maiden voyage. 1 month after delivery. USS Detroit, LCS-7, dead in the water, towed back to port like a broken-down sedan on the freeway. The Chief of Naval Operations called it the most challenging engineering problem he had seen on any class of ship in his career. That is not a minor admission. That is the top officer in the United States Navy publicly announcing that a $600 million warship failed at the basic task of moving through water. The Independence class variant had a different disease. A trimaran hull built from aluminum. 3 hulls joined by a wide connecting deck sitting on top of them. Aluminum saves weight. Weight saves speed. But aluminum fatigues under the relentless cyclic stress of ocean waves. Structural cracks propagated through the high-load junctions where the hulls connected to the deck. The Navy spent years trying to fix it. Some of these ships were decommissioned before they reached half their design service life. Ships that never grew old enough to fight. Congress called it Pentagon's floating money pit. Defense journalists called it a program that should be terminated. The Navy decommissioned 7 hulls in a single budget cycle. Ships that cost over $4 billion combined, removed from service because the math on repairing them did not work. And yet, at 0340 local time in the opening hours of Operation Epic Fury, the largest naval campaign the United States has executed since the invasion of Iraq in 2003, while our $13 billion Gerald R. Ford-class carriers held position in deep water 200 nautical miles to the south, while our Arleigh Burke destroyers held the outer perimeter, it was this ship, the broken one, the embarrassing one, that was operating inside the cage, executing 2 simultaneous missions that nothing else in the American fleet could perform. To understand why, you have to look at what Iran actually built around the Strait of Hormuz. Because this is not a defensive position. This is a kill zone with an architect. The strait narrows to 21 nautical miles at its tightest point, but the usable shipping lane compresses to 4 nautical miles. 2 lanes, 2 directions. 20% of the world's crude oil passes through that keyhole every single day. Iran spent 4 decades engineering a system designed to make that keyhole impossible to use without their permission. Beneath the surface, naval mines, contact mines, bottom influence mines, and EM-52 rocket-propelled mines that sit dormant on the seafloor and launch upward when a ship passes overhead. Behind the mine belt, more than 20 Goddard-class submarines operating in the acoustic clutter of shallow water, carrying torpedoes and additional mines. On the surface, over 1,500 IRGC fast attack craft, small fiberglass hulls capable of 50 knots, many carrying the Nasser-1 anti-ship missile. They do not fight in formation. Their doctrine is saturation. Enough mass to overwhelm the computational capacity of any defense system by sheer volume of simultaneous threats. From the air, drone swarms push hundreds of low-speed signals onto radar scopes, bleeding processing cycles from interceptor systems. And hiding inside that electronic noise, IRGC ballistic missiles descending at Mach 3, 3 times the speed of sound, the real payload masked behind cheap decoys. Do not underestimate this architecture. This is not random aggression. This is a precisely engineered anti-access system, designed around one physical constraint. The time it takes an Aegis combat system to detect, classify, track, authorize, and fire is longer than the flight time of a weapon launched from close range. At close range, inside the strait, the geometry defeats the defender. That constraint locks the carriers out. 100,000 tons of displacement, 5,000 sailors, $15 million per day in operating costs. You do not push that into a bathtub where the enemy has had 40 years to rig every square mile. So the carriers hold outside. But holding outside creates a problem that two separate mission sets need to solve simultaneously, and both require a platform operating inside the cage. The first problem is offensive. To break Iran's air defense network and open corridors for Tomahawk cruise missiles, CENTCOM needs a forward launch node close to the Iranian coastline. A platform that can push cheap attack drones into the radar net, saturate the interceptor grid, and force Iran to burn through its finite magazine on expendable targets before the expensive weapons arrive. That platform needs four things: a small radar cross-section that does not attract ballistic missile targeting solutions, speed above 40 knots to stay ahead of coastal battery fire control, a deck large enough and stable enough to launch drone swarms at sea, and a draft shallow enough to operate in the 30-foot deep coastal waters where larger warships run aground. The second problem is defensive. The strait is seeded with mines. Before a single oil tanker can transit safely, someone has to locate those mines and destroy them without putting sailors in the water inside the minefield. The Avenger-class minesweepers that previously performed this mission were decommissioned. The last 4 hulls withdrawn from Bahrain in September 2025. The replacement must carry unmanned mine-hunting systems. Robots that go where humans should not. Run every hull in the American inventory against those 2 requirement sets. The carrier fails all 4 offensive variables and carries no mine countermeasures architecture. The destroyer is not designed for mine hunting, and every vertical launch cell is too valuable to risk inside the kill zone. The submarine cannot launch drones from a submerged position. The cruiser fails the draft requirement and carries the same VLS risk problem as the destroyer. One platform satisfies every variable. The ship that failed at sea trials. But here is what nobody in the defense media understood when they were writing the obituaries. The LCS did not survive because the Navy fixed its problems. It survived because 2 of its most catastrophic failures accidentally produced the exact capabilities that Epic Fury required. Start with the Independence-class trimaran, the hull that cracked. 3 narrow hulls spread wide apart, connected by a broad aluminum deck structure sitting above the water. The cracks were real. Metal fatigue at high-stress junctions, a genuine material failure that cost years and hundreds of millions in attempted repairs. But look at what the trimaran geometry also produced. 3 hulls spread apart create a metacentric height, the distance between the ship's center of gravity and its center of buoyancy, significantly larger than any conventional monohull of similar displacement. In naval architecture, metacentric height determines roll behavior. Think of the difference between standing in a canoe versus standing on a catamaran. The wider the stance, the harder the platform is to tip. Higher metacentric height means the ship resists rolling. The deck stays flat even in open ocean swells. For a traditional warship firing guns or launching missiles vertically, roll resistance is useful but not decisive. For a platform that needs to launch rocket-assisted drones from a flight deck in sea state 3 or 4, it is the entire equation. A trimaran deck is a stable table on a moving sea. The same geometry that cracked the hull under longitudinal stress provided the lateral stability that drone launch operations demand. Now consider the second failure. The LCS was designed around swappable mission modules. Anti-submarine warfare packages, surface warfare packages, mine countermeasures packages, each built to be loaded in port and replaced based on the mission. The modularity concept collapsed. The modules arrived years late. They cost twice the projected budget. They underperformed their specifications by significant margins. The Navy abandoned the plug-and-play vision entirely and was left with a ship whose central design concept simply did not work. What that failure left behind was 11,000 square feet of unobstructed flight deck on the Independence class. Roughly the footprint of 3 tennis courts. Open, flat, stable, empty because the modules it was supposed to carry never materialized. That empty deck was not designed to be a feature. It was abandoned real estate left behind by a failed program vision. And abandoned real estate is exactly what you need when the mission is bolting a rocket-assisted drone launcher onto a warship with no structural modification budget and a 90-day deployment timeline. The engineers did not fix the LCS. They ran the equation again and discovered that the failures had become the features. In December 2025, USS Santa Barbara, LCS-32, operating in the Arabian Gulf, ignited a rocket booster on her flight deck. A small delta-wing aircraft climbed into the sky. That was the first shipboard launch of Locust, the low-cost UAV swarming technology platform, a one-way attack drone carrying a warhead that costs $35,000 per unit. 2 months later, that weapon went to war. Locust is not a simple copy of anything. Its delta-wing aerodynamics were studied from Iran's own Shahid 136, one of the most effective one-way attack drones fielded by any military in the last decade. American engineers kept the physics that worked and rebuilt everything else. 3 upgrades separated Locust from the concept it studied. Propulsion first. The original Shahid runs a noisy 4-cylinder engine that broadcasts its acoustic signature across open water. Locust runs a DA215 two-stroke engine, 215 cubic centimeters, 20 horsepower, with electronic fuel injection. The acoustic reduction is significant enough that radar detection replaces sound as the primary warning. It doesn't arrive silently, but it arrives quietly enough that by the time a radar system classifies it as a threat and generates a targeting solution, the intercept window has already compressed. Guidance second. The original Shahid follows pre-programmed GPS coordinates. Fire and forget. Fixed target only. Locust maintains a continuous uplink through the Starlink low Earth orbit satellite constellation. That connection eliminates the radar horizon limitation, the physical barrier where the curvature of the Earth blocks line-of-sight targeting. Through Starlink, a command center located hundreds of miles away can redirect a Locust against a moving target that no sensor on the launching ship can even see. Human in the loop. The trigger still requires a person. The precision requires a satellite. Iran spent 40 years engineering a toll booth. Locust drove a $35,000 motorcycle through the barrier, while the $5 million SM-6 interceptors stood at the gate waiting for something worth shooting at. Coordination third. Locust carries swarming algorithms that allow drones in a formation to share trajectory data, allocate targets between themselves, and coordinate approach vectors without human input between launch and impact. A single Locust is a nuisance. 12 Locust drones arriving simultaneously from 4 different compass bearings is a computational crisis for any air defense battery with a finite number of interceptor channels. When Epic Fury commenced, Locust swarms launched from LCS flight decks and struck IRGC early warning radar installations along the coastline. They hit command and control nodes. They struck mobile missile launcher positions that had been tracked by satellite for 72 hours before the operation began. Each $35,000 drone that forced Iran to fire a $5 million interceptor was not just a tactical exchange. It was a deliberate economic attack on Iran's finite air defense magazine. You cannot reload an interceptor battery in the middle of a strike package. What Iran's operators watching their radar scopes did not know was that the drone swarms they were tracking were not the main attack. They were the door openers. While IRGC air defense batteries were saturating their interceptor allocations against Locust formations, Arleigh Burke destroyers holding position 80 nautical miles to the south opened their vertical launch cells. Tomahawk Block V cruise missiles, each carrying $2 million worth of precision guidance and high-explosive warhead, flew northwest through the corridors that the $35,000 drones had just carved through Iran's radar coverage. The expendable drone does not kill the hardened target. It blinds the system that protects the hardened target. The Tomahawk finishes the job. For the first time in the history of naval warfare, the United States Navy synchronized expendable one-way attack drones with strategic cruise missiles inside a single kill chain in actual combat. Somewhere in Bandar Abbas, an IRGC admiral watched his radar screens go quiet and understood what had just happened. He had spent 40 years building a system designed to exhaust American precision weapons. The Americans had just built a system that exhausted his defenses with $35,000 aircraft and then sent the precision weapons through the gap. 300 nautical miles to the northwest, a second mission was running on the same map. USS Canberra, LCS-30, had arrived at Naval Support Activity Bahrain in May 2025, the first Independence-class hull to deploy with a full mine countermeasures mission package installed. USS Tulsa, LCS-16, and USS Santa Barbara arrived within 3 weeks. 3 LCS platforms, each carrying a suite of unmanned systems engineered around a single operating principle. The ship stays outside the threat zone. The robots go in. The Common Unmanned Surface Vehicle, a remotely operated boat, tows the AN/AQS-20 mine hunting sonar through suspected minefields at controlled speeds. The sonar maps the seafloor, identifying objects by shape, density, and magnetic signature. The operator sits aboard the LCS miles away from the minefield, watching a data feed. No sailor in the water. No crew inside the threat envelope. From the flight deck, MH-60S Seahawk helicopters carry 2 additional detection systems operating simultaneously. The AN/AES-1 airborne laser mine detection system scans the water column with a blue-green laser capable of detecting floating and near-surface moored mines that bottom sonar cannot reach looking upward from below. Once a mine is located, the AN/ASQ-235 airborne mine neutralization system deploys an expendable unmanned underwater vehicle, a small autonomous robot that swims to the mine's position and destroys it. 3 detection layers. 3 unmanned systems. 0 sailors in the water. The Avenger-class minesweepers that performed this mission before operated their crews directly inside the minefield. Sailors on the hull, sweeping gear dragging through mined water. LCS eliminated that variable entirely. The crews that would have been at risk inside the strait were 4 miles away, drinking bad coffee and reading sensor data. Over the course of Epic Fury, LCS-mounted unmanned systems cleared mine corridors through the strait that allowed carrier strike group logistics to flow and set the conditions for commercial transit to eventually resume. Iran had seeded those waters with an estimated 2,000 mines over a period of years. The robots found them. The robots destroyed them. The sailors watched. 2 missions, same class of ship, running simultaneously on the same map. One punching holes in Iran's air defense architecture, the other clearing the floor of the cage that Iran had spent 4 decades rigging. Now watch them converge. At 0410 local time, CENTCOM released the satellite imagery. Bandar Abbas Naval Base. Iris Jamaran, a Mujh-class frigate and one of Iran's most capable surface combatants, was struck and sunk at the pier. Hull partially submerged, the superstructure still visible above the waterline. Iris Bayandar and Iris Nagdi, both corvettes, destroyed at the same base without reaching open water. Iris Shahid Bagheri, the converted cargo vessel that the IRGC had spent 3 years welding an angled flight deck onto, transforming a commercial freighter into a makeshift drone carrier, structurally destroyed at the berth where she was born. Iris Makran, hull number 441, a converted oil tanker serving as a mobile forward support base, heavily damaged at anchor. Here is the detail that rewrites the entire story. Look at what was destroyed at Bandar Abbas. The Shahid Bagheri, Iran's answer to drone warfare at sea. A cargo ship with a flight deck welded onto it. Years of engineering work. Millions of dollars. An entire asymmetric doctrine built around the idea of projecting drone power from a platform that didn't look like a warship. It never launched a single combat drone. It was destroyed at the pier by drones launched from a ship that our own Congress voted to scrap. Iran built a drone carrier from scratch and lost it at birth. The United States took a ship with cracking aluminum skin and a self-destructing gearbox, a ship that 2 different naval chiefs had called an embarrassment to the program, and turned it into the drone carrier that won the opening phase of the largest naval campaign in 20 years. That is not irony. That is engineering finding the right variable. More than 100 Iranian naval vessels were destroyed or rendered combat ineffective across the course of Epic Fury. The surface fleet that was designed to swarm and overwhelm American forces in the shallow coastal waters ceased to exist as a coherent fighting force. The mine barrier that was supposed to seal the strait was systematically dismantled by robots operating from the flight decks of ships that were never supposed to survive long enough to field them. Now you have the data. Go back to the question. Why the most broken ship for the hardest mission? Because the equation did not ask for the best ship. It asked for the right ship, small enough to enter the cage, fast enough to stay ahead of a targeting solution inside it, a deck wide enough and stable enough to launch drones in open ocean conditions, a displacement low enough that losing one does not restructure the fleet, cheap enough that CENTCOM could push 3 of them into the kill zone simultaneously without that decision requiring a congressional notification. Run those variables against every hull in the American inventory. Only one answer comes back, the same one both times. And that answer did more than the equation required. It launched the first combat drone swarm from a warship in the history of naval warfare. It deployed the first fully unmanned mine countermeasures architecture in a live minefield. It operated inside a threat envelope that our most expensive platforms could not enter. And it survived because 41 knots of speed and 3,000 tons of displacement do not generate the radar and thermal signature that attracts ballistic missile targeting computers. The engineers did not fix the cracked hull. They did not repair the failed modules. They ran the equation again, and the failures became the features. The empty deck that modularity left behind became a drone launch platform. The trimaran hull that cracked under longitudinal stress provided the lateral stability that rocket-assisted launch operations require. The low unit cost that defense journalists cited as evidence of cheapness became the acceptable risk calculation that let CENTCOM push 3 of them into the teeth of Iran's coastal defenses on the same night. LCS was never a good ship. It was the right variable. And in the opening hours of Epic Fury, the equation worked. If you enjoyed this video, check out our other video on how Iran's mine warfare doctrine was designed to stop a carrier strike group. Bye for now.